Welcome to this explainer. Today, we're basically turning you into a mathematical detective as we decode the secrets of estimating systems of equations graphically. I am super excited to guide you through this because we aren't just plotting lines on a grid today. We're actually talking about how to uncover the truth when the answers aren't perfectly, obvious. But before we even look at a single number or graph, our source text roots this whole lesson in a really interesting place. It points to Proverbs 1 verse 5. Let the wise hear and increase in learning, and the one who understands obtain guidance. It's a great reminder that true learning is really about actively seeking guidance and uncovering the truth. It's the perfect foundation for our mathematical investigation. Okay, here is our roadmap for today. We're hitting 1. Seeking truth in math. 2. Why estimation really matters. 3. The 3-step estimation method. 4. Testing your math estimates. 5. Your homework mission. And 6. Education and biblical morality. Let's jump right in. Part 1. Seeking truth in math. Let's tackle a huge myth right off the bat. The idea that math always gives us perfect, neat, whole numbers right away on a beautiful, clean grid. Yeah, right. If you've spent literally any time graphing equations, you know that is simply not the case. So here is the big idea. Sometimes you draw your lines, and the solution just does not land perfectly on a neat point. When an intersection hides somewhere between the grid lines, especially when decimals are involved, we have to use our deductive reasoning skills. We make a smart, logical estimate using the graph, and then, crucially, we test it in both equations. You don't need perfect numbers to find the truth. You just need a solid analytical method. Moving right along to Section 2, Why Estimation Really Matters. Now, you might be thinking, why go through all this effort? Why not just use a calculator for everything? Well, estimation isn't just busy work. It is absolutely a real-world superpower. Look at these applications from the source. Estimation is used to budget finances, engineer massive structures, and even determine medical dosing. It teaches you how to make informed decisions when exact answers just aren't handed to you. In math, this is exactly how we figure out what's close enough and use pure logic to back it up. That brings us to Section 3, the 3-step estimation method. Let's break down the actual mechanics of this into an easy-to-follow process. All right, here is your toolkit. Step 1. When the solution isn't obvious, observe the intersection. Just look closely at where the two lines appear to meet on the graph. Step 2. Document your best guess. Write down the x and y values you think represent that point. And Step 3. Interrogate those clues. Substitute your guessed values back into both equations to test them. If both values come out really close, boom, you've got a good estimate. Remember, your estimates don't have to be totally flawless, but they do need to make logical sense. And naturally, the cleaner your graph is, the better your guess is going to be. Let's actually put this to the test in Section 4, Testing Your Math Estimates. Time to head into the lab and look at some concrete evidence. Okay, look at example 1. Imagine two lines intersecting slightly between the coordinates 2, 4, and 3, 5. We estimate the intersection is around x equals 2.5, y equals 4.5. Our equations are y equals 2x and y equals x plus 2. Let's test that guess of x equals 2.5. In the first equation, 2 times 2.5 gives us a y of 5. In the second equation, 2.5 plus 2 gives us a y of 4.5. Since our resulting y values of 5 and 4.5 are super close, we've successfully found a solid, reasonable estimate. Make sense? Now check out example 2, which brilliantly illustrates what a perfectly close estimate looks like. The graph shows an intersection near 1.2, 3.6. The equations are y equals 3x and y equals negative x plus 4.8. When we substitute x equals 1.2 into the first equation, 3 times 1.2 equals exactly 3.6. In the second equation, negative 1.2 plus 4.8 also equals exactly 3.6. Substituting 1.2 gives us exactly 3.6 in both columns. We cracked the case perfectly. But hey, what happens when things just don't line up? In example 3, we estimate the intersection is at 4, 1.5. The equations are y equals negative 0.5x plus 3 and y equals x minus 2. So we test x equals 4. The first equation gives us a y of 1. The second equation gives us a y of 2. Well, our results of 1 and 2 aren't close at all. But that's totally fine. It simply means our estimate doesn't satisfy both equations. So we just adjust our guess slightly, maybe move our x down to 3.5, and try again. Seeing these outcomes side by side highlights something super important. A failed estimate isn't actually a mistake. Seriously, it's just a necessary step toward adjusting your aim. It tells you what isn't the answer, which guides you right to what the actual truth is. All right, Section 5, your homework mission. Now it is your turn to step into the detective's shoes. I want you to tackle these 4 specific challenges from the source text, practicing exactly what we just did. Number 1, graph y equals x plus 1 and y equals negative x plus 5 and estimate their intersection. For number 2, 2 lines appear to cross around 2.2, 3.1. Check that estimate using the provided equations. Number 3, estimate the solution from a graph for the next set. And finally, number 4, test the estimate 5, 4 in the last set of equations to see if you're close. And while you're crunching those numbers, I also want you to answer this crucial question from the text. Why is it important to test your estimate in both equations? Give me a solid 1 to 2 sentence explanation. Reflecting on the underlying logic, the why behind the how, is what really separates good math students from great truth seekers. Finally, let's wrap up with Section 6, Education and Biblical Morality. As we finish out the math, our source material zooms out to look at the broader philosophy behind why you're seeking truth in the first place. The HeroesMart Academy Godly Learners series, which we're exploring today, asserts a profound concept. Education without morality will hurt. The source poses a really deep question to reflect on. What is the point of being smart and highly educated if we just continue making bad choices that cause hurt? According to this framework, true education has to be paired with morality. The text draws a fascinating parallel here. Just as finding the correct intersection on a graph brings mathematical resolution, the source emphasizes that aligning your mind spiritually brings ultimate peace and clarity. It references Romans 8, verses 6 through 7, noting the promise of peace of mind to everyone who keeps their mind spiritual, a core idea in this educational approach. Which leaves us with this final, provocative thought from the text to ponder today. If finding truth in math requires such careful observation, estimating, and rigorous testing, how do we validate our daily choices to ensure they bring peace instead of hurt? It really challenges us to ask. Just like we check our equations, are we actively checking our life's choices to make sure they align with the truth? Take that with you and keep actively seeking the truth in all that you do.